This is Unit 3, Triangles. Lesson 3.2, Triangle Inequalities and Isosceles Triangles. Students, you should be right here. Make sure you write down both the location, the date and time that you are watching this video. Don't forget to get a parent or signature sign-off. All right, we're going to do a quick review problem. The key to this problem is three different things. One, you want to watch out for linear pairs, which are angles that share a spine and make a line. Two, we want to watch out just for the fact that triangles add up to 180. And the third thing you want to watch out for is that that exterior angle, these angles on the outside, add up to the two remote interior. You want to watch out for those three items. So taking a look here, starting with this, the first thing I'm going to do is sweep all the linear pairs. Ready? Sweep. That adds up to 180. Sweep. That adds up to 180. Sweep. That adds up to 180. This adds up to 180. Okay, so your goal is, at the squeeze a sponge problem, is I want you to find every single angle in the diagram. Pause the video, find the angles, and then restart. Alrighty, students, welcome back. Let's start with these angles that are a linear pair. We're going to do 180 minus 55, and we get 125 degrees. So this right here, 125 degrees, which you should have gotten the vertical. 125 degrees is here, 95. So 180 minus 95. Going to be 85 right there, and this is going to be obviously 100 degrees. Now you want to look for other kinds of angles. We can get this angle here because it's vertical to the 55, and then we can add 85 plus 55, take it away, that's going to be 140. Then we're going to take 140 away from 180, and of course we get 40. That means this angle right here is 40 degrees, which if this is 180, this has to be 40 over here. And if that's 140, that means this angle way over here has to be 40 as well. Take a quick look, see if we found all possible angles, and we have. And again, what did we use? We used linear pairs and the fact that triangles add up to 180. Today we're going to talk about triangle inequalities and isosceles triangles. You want to look for these specific words: inequality, range, of course the unknown, greater than, less than, something called monkey face, which doesn't make any sense now, but just go like this. That's going to look like monkey face. We'll explain it in just a moment. Vertex, something called legs, and base angles. You should have some colors and a straight edge handy today. Now, let's take a look here. I want you to label the sides. Just label the sides visually. You don't need to get a ruler out. Label the sides short, medium, long. Just do that right now. I'll give you about 30 seconds. Do it on your own. Short, medium, and long. Go. All right, you should have labeled this, of course, the short side. This would be the medium side. And of course the green here is the long side. There's a very simple relationship. The angles, the order of the small, medium, large angles match the short, medium, long sides. For example, this is obviously the smallest of the angles. And if you go straight across from the short side, you have the smallest angle, which gives us this very simple concept. The small angle of a triangle is across from the short side of the triangle, directly opposite. So if you trace the short side and you go directly across, behold, you're going to get the small angle. Same is true of the middle angle. This is obviously the middle angle. So the middle angle, excuse me, that's not the middle angle. That's the largest one if you were to take a protractor to it. This is the middle angle. And the middle angle is directly across the medium side. And of course, this is the large angle. And it is across the long side. So the small angle is across the short side, the medium angle is across from the medium side, and the largest angle of a triangle is across from the long side. This is true of all triangles. Now, what happens when a triangle isn't unequal? What happens when you have equal sides? When you have equal sides, you're going to start getting equal angles. Unequal sides, they correspond small to the short, medium to the middle, large angle to the long side. But when sides start getting equal, so do angles. We're going to talk about that in about 15 minutes. So here we have a triangle, TUV. Don't really know what the triangle looks like, so I'm just going to label it here, TUV. And T to U is going to be 3 units in length. So this is 3 units. And U to V is 4 units. And T to V, of course, is 6 units. So now, notice we have no angle measures, but I want you to label the angles from greatest to least. So I'm going to write here, I'm going to have angle from the greatest to the least. In other words, from the larger to the smaller. And it's really simple. All you have to do is, if this is the longest side, this angle right here is the largest angle. So the largest angle is going to be angle U. Medium side, medium angle. The medium angle is going to be angle T. And the smallest side is across the smallest angle, which is going to be angle V. Using this concept, I'd like you to order the sides here from least to greatest. In other words, from short to long. Pause the video, do that, restart the video. Welcome back. Okay, so you start with the smallest angles, that's 35. Notice I swept it. That's the small angle, which means this is the short side. Small, short. So VU, UV, same thing, it doesn't matter. And then here we have the medium angle, 56. The middle angle gives us the medium size, which in this case is going to be TU or UT, doesn't matter. Last one, you have the largest angle, and that gets you the long side, which is going to be TV or VT, same thing. Now there's a way to test, because of this triangle inequality, dealing with the inequality of the sides and the inequality of angles, there's a certain test here which says if you have any three numbers, and this is a common SAT question, you're given any three numbers and you're asked, could this make a triangle? Now there's a couple ways you can do this. You could actually cut slips of paper and see if it works, and we're going to try that in class. Or there's a shortcut here. A shortcut says this, that when you have a triangle, any two sides of the triangle have to add up greater than the third side. If that's not true, it can't be a triangle. So for example, in this triangle, it obviously is a triangle, we can do this. We can add 7 and 4, and that's going to be greater than 8. And that's a true statement, because 7 and 4 add up to 11. So that's a true statement. And then we can do this. 8 and 4 have to be greater than 7. If you add these up, that's 12. Greater than 7, that's a true statement. And the last one, 7 and 8, have to add up greater than 4. If you add those up, it's 15. That's a true statement. So the segments 4, 7, and 8 do create a triangle. So let me show you a shortcut you can use. I call this shortcut monkey face. Ready? Let me show you what I mean. Common SAT question. You can determine whether these three can be a triangle. Is you do what I call eyebrow, eyebrow, smiley. Eyebrow, eyebrow, smiley. Call it a monkey face. Ready? This is what this looks like. Eyebrow, eyebrow, smiley. So we're going to go 6 plus 8 has to be greater than 10. That's one eyebrow. The other eyebrow is 8 and 10. So 8 plus 10 has to be greater than 6. Smiley, 6 plus 10 has to be greater than 8. Now you go through and you ask, is it true? So this is 14 is greater than 10. This is true. And of course this here, that's 18 is greater than 6. This is true. And this, of course, is 16 is greater than 8. This is true. When you do monkey face, if all three are true, 1, 2, 3, you can write, yes, it is a triangle without even drawing it. Let's try another one. Ready? Eyebrow, eyebrow, smiley. So now we go through and we determine whether or not the two on the left have to be greater than the one on the right. 6 plus 8 is 14, so that's an equal sign. 8 plus 14, that's 22, that is greater than 6. 6 plus 14 is 20, that's greater than 8. But right here, there's an equal sign. So overall, this is a no. If any single combination, two sides are not greater than the third side, then no, that cannot be a triangle. I want you to do monkey face with these sets of numbers to determine whether or not it's a triangle. Pause the video, do the work, restart the video. Welcome back. Let's check. We're going to do eyebrow, eyebrow, smiley. So I'm going to go 16 plus 10. I'm going to put a 6 there. I'm going to do 10 plus 6 and 16. Smiley, 16 plus 6 and 10. For this one, yes, that's a greater one. This is an equal. Yes, that's greater. Since there is one equal sign, this is a no, yet that cannot be a triangle. This is a very common SAT question. Watch for it on your SAT day, PSAT day. We started this with the understanding that when you have a short, a medium, and a long side of the triangle, that somehow the angles are related to the sides directly across from it. The angles are related to the sides directly across from. This is true even when those sides start getting to be equal. So I'm going to introduce some vocabulary that is specific to an isosceles triangle alone. Isosceles, as you learned in a previous lesson, means you have two congruent sides. So, in an isosceles triangle, the two sides that are equal, those are called the legs. So just write leg and leg. That's the two congruent sides. Those are called the legs. The vertex is the hinge between the legs. The vertex is the hinge between the legs specifically. It does not always mean the top point. It has to be hinged specifically between the two legs. Now, in a isosceles triangle, the base is the third side that's not congruent. And the base is always opposite of the vertex. So the base and the vertex are always opposite of each other. The angles that are connected to the base, there's two of them, those are called the base angles. So connected to the base is a base angle. So base angle, base angle. These are the four key vocabulary words you need to understand about isosceles triangles. Now, just like you learned, the largest angle is across the smallest side. When things get equal on sides, angles start getting equal. Let's start with something simple. If we have two equal sides, so trace and put those hatch marks in there, please. Trace and put those hatch marks in. This is your vertex. If you have two equal sides, then the base angles are congruent. So watch. This hatch mark, please draw this arrow. This side is opposite of that angle. Draw that arrow, please. please draw the arrow. Put your pencil on the paper and draw that arrow. This hatch mark kind of points to this angle right there. If those two sides are equal, these two angles are equal. So if the two sides are equal, the two angles are equal. And it's the angles that are opposite of the equal sides. So if you have an isosceles triangle, the base angles are congruent. The converse is true. Remember, converse means to switch that order. If you have two equal angles, if you have two base angles that are equal, so sweep and hatch those marks. Ready? I'd like you to draw this arrow. Follow that hatch mark to that side. Draw an arrow, please. Now ready? Follow this hatch mark to this side. Draw an arrow, please. Please put your pencil on the paper and draw those arrows. If you have two equal angles, then you have two equal sides. So let's recap where we've been. Down here, real simple. If you have two equal sides, you have two equal angles. Up here, two equal angles, two equal sides. Now, there's a couple other qualities that are pretty unique to an isosceles triangle. And if you have an isosceles triangle, which implies two equal sides, so go ahead and draw. That's isosceles. Then, the median, let me define the word median. You haven't seen that before. That's a segment that goes from a triangle corner to the opposite midpoint. Put that right on top of that. I'm going to repeat that 3 times. What is a median? A median is a segment that goes from a triangle corner to the opposite midpoint. A median goes from a triangle corner to an opposite midpoint. One more time. A median goes from a triangle corner to an opposite midpoint. So if we draw the median from the actual vertex, vertex meaning the hinge of the equal sides, so we're going to go to the opposite midpoint. So there's our midpoint. Hatch marks down there. If we draw that median, that goes from the vertex to the opposite midpoint. That, my friends, is called a median. It goes from a vertex to the opposite midpoint. Vertex to the opposite midpoint. Then that median does 2 things. Those 2 things are, it bisects the vertex angle, so hatch mark here. It cuts that vertex angle in half, and it's right angle to the base. And this is only true in an isosceles triangle, the median from the vertex. That's unique to an isosceles triangle. When I say isosceles, of course, the same is true of an equilateral triangle, which is 3 sides equal. Alrighty, let's do a couple problems. Okay, notice the sponge there. Sponge means find everything possible. First thing you want to do is simply trace the equal sides. So we're going to go through and trace the two sides that are equal. Just go through. I'm tracing the equal sides. That's all I'm doing, tracing the equal sides. Now, I want you to go through, and we're going, as you trace the hatch marks of the equal sides, we're going to draw our little arrows and find the hatch marks of the equal angles. So, for example, if these two sides are equal, I'd like you to kind of, with those hatch marks point to this angle, these hatch marks point to that angle. That means these angles have to be congruent. So sweep, hatch, sweep, hatch. Let's do this too. Ready? Darken the hatch marks. As you darken the hatch marks, draw the arrows to the corners of which they're pointing, which are these way. Now we're marking these equal. Alrighty, now that you know which angles are equal, our job is to look for these things. We want to watch out for linear pairs, which add up to 180. We also want to watch out for bow ties, which are congruent, or vertical angles. Last thing, of course, we want to work with the fact that triangles themselves always add up to 180 degrees. So watch out for those three things. Let's start with this. We're going to sweep all our linear pairs. That's a linear pair. We have a linear pair here. We have bow ties here. Watch those. Do you see them? We have bow ties here. And of course, we have two triangles that add up to 180. Let's start working it here. I'm going to start with that 110. Zoom in real close here. Ready? If that's 110 and this is 180 degrees, we know that this here must be 70 degrees. And if it's 70, we know that those two red angles are equal. That means this is 70, which means bow ties. That's 70. And then we have a couple linear pairs here, which means this is 110, this is 110. We know triangles add up to 180 degrees, so we can add 70 plus 70, which is 140. Take it away from 180, that means this right here must therefore be 40 degrees. That's 40. We have a bow ties here. That's 40. That means from one here to here has to be 140. We follow it down. See that red there? This corner has to be equal to this corner because two equal sides, two equal angles. 40 plus 40 adds up to 80. Take away from 100. That means this right here is 100. Now take a quick scan. Do we have everything? We do. So now I want you to do this. Again, watch out for bow ties, vertical angles. Watch out for linear pairs. Share a spine, make a line. Also watch out for the fact that if you have two equal sides, you have two equal angles. I want you to do this one down here on your own. Find everything possible. Go. Alrighty, welcome back. Step number one, you should have found the congruent angles by doing this. If these two sides are equal, You follow it down, tracing, see the little arrows? That means these two angles are equal, right here and right here should be equal. Again, these two sides are equal here. You follow it down, that hatch mark points to this corner, this hatch mark points to that corner. That means these angles right here are congruent. Now we start looking where we can get some numbers from, and we see here we have a 103. So I take 103 away from 180. Of course, that's going to be 77. That means this angle right here is 77 degrees. Hatch marks, that means this is 77. So I add 77, get 154. Take away from 180. You get 26. That means from here to here, if you look really carefully, that's 26. Now I'm going to zoom in because this, some of you probably overlooked. Did you notice that right angle box there? That means from here to here, there was 90 degrees. If that's 90, from here to here, to get this, we have to go 90 minus 26. We should have gotten 64 degrees here. That's 64. Hatch marks, bring it over. That's 64. And you add 64 and 64, that's 128. Take it away from 180. That means this right here is 52 degrees. I go like that. That's 180. I take away 64 from 180, and I can get angle 2 here. So 180 minus 64. You get 116. That means this is 116, and of course this was a bow tie or vertical angle 64. Students, circle the sections that you missed, double check it, write yourself a little note, and watch out for that in class next time.